Hello everyone, today we will be sending bigger payloads through the Helium network or the TTN network. So let's jump straight into it. So first let's describe the problem. Let's say we have a big payload that is greater than 256. If the range is greater than 256, we cannot send it directly over the network because, as we discussed in the previous video, the payload variable only works in a 1 byte interval, so 8 bits. So the maximum range per interval is 256. Now we have a couple solutions for this. I will just quickly explain two of them. We have solution 1, which is modifying the payload, and then we have solution 2, which is using additional bytes. So in solution 1, let's first describe the scenario. Let's say we have a barometer that displays a value between 900 and 1100 hectopascals. This is obviously greater than 255 or greater than the range of 256. So this is, we can send this value directly. However, the range is only 200. So 1100 minus 900 is only 200. And 200 is less than 255. So we could send the range of the value. So what we can do is say the value to be sent is equal to the value of the barometer minus 900. So let's say the value of the barometer is 900, then the value to be sent is 0. If the barometer value equals 1100, then the value equals 200. So 1100 minus 900 equals 200. And then later in the decoder, so not on the device, we say that the value of the barometer equals the value that we received plus 900. So let's say the barometer shows a value of 1000. We do 1000 minus 900, which is 100. Then we receive 100. We add again 900 to it, and then the value of the barometer that we read equals 1000. So this is a pretty easy way to send big payloads over the network without actually using a lot of payload capacity. So then, how does it actually look in Arduino? So first I created a value of the barometer, 1100. I didn't attach a real sensor just to simplify it. So then we create a byte, and then we say, okay, the byte that we are going to send is equal to the value of the barometer minus 900. Then we send that data, so just the byte value that we sent. And then in the decoder, this is in the Helium console, we say bytes that we defined here, first byte plus 900. And then in Google Sheets you should see the 1100 again. Solution 2, let's say that the value can actually dip below 900 and can actually go above 1100, because in the previous solution you didn't care about the values between 0 and 899, but let's say now you do actually care about them. Then solution 1 is not really a great solution. Solution 2 is actually using additional bytes, because if you use 2 bytes, you now have a range of more than 60,000, which is obviously greater than 1100, so we can just directly send that data. So the value to be sent is then equal to the value of the barometer. As I said earlier, the payload is always declared in 1 byte intervals, so we cannot send 2 bytes directly. So how are we gonna fix this? We're gonna fix this by splitting the byte into 2 separate bytes. So we say the value to be sent is equal to the high byte of the value of the barometer plus the low byte of the value of the barometer. And you might say, how does that look like? Well, we basically say, let's say the value is 1100. We convert this into binary, and we say, okay, the high byte, which is the first 8 bits, and the low byte, which is the last 8 bits, we basically chop that in two, and then we have 2 different variables that we can actually send, because the payload again needs to be in 1 byte interval. So this is 1 byte and this is 1 byte. So then we can send this over the network. So then in the decoder we have some problems, because if you just add these values up, you see this is equal to 80 and that's not equal to 1100. And you might say, why? Well, that's because this value is actually not equal to this value, to the value that we actually want. This value needs to append 8 zeros to it. This is the value that we actually want. So this is what we receive, but this is what we need to add the value so we have the correct value. So how do you actually do this? Well, there are a couple of different ways, but the most common way is to left shift. Left shift is basically where you put the byte that you find on the first one and just move it to the left, and then to the right add a 0. And you can do this a bunch of different times, and then at the end you will see a byte with a lot of zeros at the end. So in our case we need to add basically another byte, so we need to left shift 8 times so that we have the correct value. So if we actually look at the correct data now, so the value of the barometer equals the high byte, but left shifted 8 times, plus the low byte, so then we have 1024 plus 76 equals 1100, which is the correct value. Now, how does that look in Arduino? It's pretty easy. Again, we define the variable of the barometer, then we declare a high byte and a low byte, then we send that high byte and low byte. Again, do not put plus low byte here on one interval, because you need 2 of them, because it's only one byte. So in a decoder, then it's a little bit more complicated. So we first take the high byte, as I did here. I sent the high byte first, so the high byte has index 0. So we first left shift that 8 times, so you can see the arrow points to the left, so that means left shift 8 times. If you put them to the right, you will right shift 8 times, which is, that would not work here. So we left shift 8 times, then we add the other value, the 76, and then in Google Sheets you should see the correct value. Now what about floats? Let's say you have a barometer value that is actually pretty accurate and it says 1100.14. Well, there are a lot of different solutions to send this data. Solution A is to just get rid of the decimal places. Let's say you don't find this important, the 0.14, then you can just use the round function, and then you get 1100, and then you can either use solution 1 or 2. Solution B is just multiply the value by 1000, and then use solution 1 or 2 or a combination of the two. Now do keep in mind, if you just use solution 2, then you will need 3 bytes instead of 2, because if you multiply this value by 100, you will get 100,000, which is greater than 60,000. Now what I would do is I will just multiply this value by 10, then use the round function to get rid of the 4, and then just use solution 2, because then we only have 10,000 instead of 100,000, and it's still reasonably accurate. But if you need the high level of precision, then you can use additional bytes. So that is it for this episode. I know it was a little bit complicated, but I hope you learned something. In the next episode we will connect the sensor and actually send some sensor data through the network.